In this video, we're going to talk about angles on a coordinate plane in what's called standard position and how that relates to some trigonometry. Alright, so looking at these examples on page 38, notice how each of these examples has what's called an initial side, which is on the x-axis, and then a terminal side that forms an angle measure. When we have something in standard position, that means that we have our angle starting at the x-axis. Alright, this example, or these examples also show us a direction of an angle. So notice in this first example we have a direction of angle arc moving counterclockwise. This is in quadrant 1, and so we know based off this that we're going to have a positive angle measure. Here, when I'm going clockwise and I'm in quadrant 4, I'm going into a negative angle measure. And then here I have an obtuse angle made by the initial side and terminal side. This is going to be positive because it's going in a positive direction. And then here, notice when we're using angle measures, or we're using, for instance, degrees, a full rotation is 360. Now notice this angle measure will be 360 plus the little piece it takes to get from the initial side to the terminal side after a full rotation. This is in the negative direction, so this angle measurement will be negative. So if I had a angle in standard position, which means the initial side is on the x-axis, I can get a point from the terminal side and draw an altitude to the x-axis. So looking at this example here, I have an initial side and a terminal side, and then a point which are written as coordinates x and y, meaning I have an x distance and then a y distance, which when I drop an altitude to represent the y distance, I end up having a right triangle. And so what we know about right triangles is we can use the sides of a right triangle as well as an angle measure to find different parts of that triangle using trig functions. And so you'll remember SOHCAHTOA, where looking in this example, theta is our angle measurement we're using, and so the sine of theta would be opposite over hypotenuse, which in this situation is y over r. Cosine adjacent over hypotenuse, which in this situation is x over r, and then tangent, which is opposite over adjacent, which in this situation is y over x. And so we're going to be able to use these trig functions a little later on to find all the missing parts of our triangle. So now looking at page 38, when you look at all of these angles in standard position, notice each angle has an acute angle with the x-axis. These acute angles with the x-axis are called my reference angle. And we're able to use the reference angles to find different angle measures as marked by an angle arc. So with angle measurements, we also learned a new measurement called radians. So we should be able to draw an angle in standard position in radians or degrees and identify the reference angle by dropping an altitude. So let's look at an example of what that means. So looking at number 1 on page 39, 7 pi over 12. So if you remember, when we were talking about radians and a full rotation in radians, think of it on a coordinate plane, started at 0, a half rotation in radians was pi, and then a full rotation was 2 pi, which made this piece here pi over 2, and then this piece 3 pi over 2. So when we're graphing or sketching angles in standard position with radians, I would write out what we know about a full rotation in radians. So what I mean by that is a full rotation in degrees is 360, while a full rotation in radians is 2 pi. So then, looking at your angle measure, which is 7 pi over 12, we can convert all of these radians into a radian measure they give us to make it a little easier. So for instance, my denominator is 12. All right, and so 1 pi can be rewritten as 12 pi over 12 because 12 over 12 is 1, which makes pi over 2 can be rewritten as 6 pi over 12 because 1/2 pi is also 6 pi over 12. 6 over 12 reduces down to 1/2. So then 7 over 12 is just slightly past 6 pi over 12, so I'm going to draw my terminal side and highlight the initial side. And then you want to make sure you mark the correct direction of your angle measurement. So notice here how I have drawn a angle arc and then an arrow to show the direction. That angle measurement shows 7 pi over 12. So now if I wanted to find my reference angle, I would drop an altitude to the x-axis. We always drop an altitude to the x-axis. And we can find this small piece here, which is considered my reference angle. And so to find your reference angle, I need the radian measure that will get me from 7 pi over 12 to 12 over 12. And to do this, you can take 12 pi over 12 and subtract 7 pi over 12 from it, which would then give us 5 pi over 12 as our reference angle measurement. All right, so let's look at another example of this. I'm going to skip and go to number 5, where we have -5 pi over 8. All right, once again, draw an axis with 2 pi, pi over 2, and then 3 pi over 2. And then convert all of these using the angle measure they give us. So they give us one where it's 5 pi over 8, so I'm going to use the denominator, which makes 1 full pi, or a half a rotation, 8 pi over 8, which would make pi over 2, 4 pi over 8, which would then make 3 pi over 2. I need a fraction that's equivalent to 1 1/2 using a denominator of 8, which would be 12 pi over 8. So notice here I have the -5 over 8. So instead of going in a positive direction, I'm going to be going in a negative direction. So if this measure here is 4 pi, we know 5 pi is going to be a little bit past the 4 pi. However, it's in the negative direction. So if I'm starting from my initial side, moving in the negative direction, I'll end with a terminal side in the third quadrant. And once again, I need to mark my angle measures with an arrow and then label that this is -5 pi over 8. And then to find the reference angle, I can drop an altitude to the x-axis and find the missing piece, or the small acute angle, which will get me all the way back to the x-axis. So this angle measure here would be 8 pi over 8 minus 5 pi over 8, which is 3 pi over 8. It's also important to know that the angle measure is, or the angle measure of a reference angle is always positive. So that's working in radians. If I wanted to do this, say, for number 7 in degrees, I would take, starting with my initial side, I would want to go 371 degrees about the origin in the positive direction. So one rotation takes me to 360, and then to determine the last piece after 360, I would say 371 minus 360, and I would get 11. And so from here, I would mark a full rotation for 360, and then all the way to my angle measure for 371. Now to find this reference angle, once again, you can drop an altitude and determine what is the measure of this acute angle. All right, since we know that one full rotation is 360, we just need to know the small piece that gets us to 371, which makes our reference angle 11 degrees. Thanks for watching.